Welcome back to Principles of Electronics. This is lesson number 10. Today we're going to be talking about SCRs. SCRs stand for Silicon Controlled Rectifier, otherwise sometimes referred to as a thyristor. I've heard that pronounced many different ways, but whatever. The different types of an SCR. This one should look very familiar if you just went through the transistor. It looks like a NPN or PNP transistor, bipolar transistor. Basically, it's the same package, but very different operation. You can also get SCRs in this package, and you can get them in this package also, all depending upon what application that you have. Now, the symbol for a SCR is going to look somewhat familiar. We all know what that is. That's a diode that has an anode and a cathode. We covered that a few lessons ago. But an SCR, and you'll notice in the name a rectifier, diodes are referred to as rectifiers. But what we're going to do is we're going to do this little kick down here, a little leg. And that little leg is called the gate. So an SCR has an anode, a cathode, and a gate. Anode, cathode, and G is a gate. Now, very similar, I'm going to kind of relate this a little bit to a transistor. If you remember, a transistor had a collector, a base, and an emitter, and when power was applied to the gate, then when power was applied to the base, current flowed from the collector to the emitter. Very similar here. When power is applied to the gate, here, current is allowed to flow from the anode to the cathode. Until that happens, this is just an open circuit. Current's not allowed to flow. Now, the nice thing about this is, if by chance we take away the power, so we apply it, we get current to flow, we take it away, current still flows from the anode to the cathode. We have to physically remove power to shut it off. This makes for a great alarm system, which is what my circuit over here does. So let's go over to our example. A lot of this, you've seen all this already. We have a battery. This is a normally closed switch. So right now that switch is in the closed position. We have a current limiting resistor for an LED, and there's our SCR. Our SCR again, our anode, our collector, our anode, our cathode, and our gate, G. Now, how would this work? So we have our battery hooked up. We're armed, which means this is an alarm system. Our switch is closed, and we're just waiting for this switch to close, because when this switch closes, we're going to get power into the gate. That's going to then close this rectifier, which will then allow current to flow. Right now, even though that switch is closed, current cannot go through that rectifier because power hasn't been applied to the gate. So we close this switch, power goes to the gate, current is allowed to flow, which means now you get current flowing this way, and it lights our LED. Or in this case, since this would be an alarm type system, maybe a flashing light you have there, or you can replace that with a buzzer or some other loud noisemaker or whatever. What I like to do is say, well, what if, let's look at an application. What if you have a buzzer here? So this is going to get sloppy real quick, but let's just say that's a buzzer. I'm going to put a B there for buzzer. And then this switch maybe is wired to your window. So you have a little switch. So if your window is opened, let's say 4 inches, a switch closes. So you have something on your window that when it opens 4 inches, it will close. 2 pieces of metal touch or whatever. And that metal goes back to a circuit for this. So you arm it. The window opens. It opens 4 inches. This switch closes. power to the gate, the buzzer goes off. Whoever's trying to open the window hears that buzzer go off. They slam the window shut, which means this switch opens again. But the good thing about this SCR is current will continue to flow, which means this buzzer is going to continue to make a lot of noise until this switch right here at the top, our arming switch, is open. And once that's open, then it's cut. Power is cut. This opens up again. Current doesn't travel through. The buzzer goes off. Now the good thing about this is we want to arm it again. We just close this switch and we're back to the arm position. So very easy component to use. A lot of applications, especially in the alarm system business. And it's called the Silicon Controlled Rectifier. Well, let's do our little review. SCR, Silicon Controlled Rectifier, comes in different packages. I only put 3 here. Again, this one looks very similar to transistor. Now, the 3 pins here are the anode, the cathode, and the gate. You have to look at the specification for that particular part to figure out which one is the anode, the cathode, and gate. A lot of times they're different, and you just have to look at the specification to make sure you know which pin is what. Highly used in the alarm industry, and here's a very simple little circuit. I have a lot of students do this circuit to begin their exploration on SCRs, and it works out pretty good. A lot of different ways that you can have some fun with this circuit. All right, so that is SCRs for now. If you have any questions, please leave them in the comments. And as always, please subscribe to Sprider Web Education.